We have our dear friend Mohsen Bahrami for the first of our summer seminar series. Mohsen is currently a postdoctoral associate in the Connection Science group within the MIT, and his research field is computational social sciences. He has been working on data-driven behavioral analytics to analyze, describe, and predict individual and group behavior using large data sets from various industries. He conducted academic research and completed industry projects under supervision of Professor Alexander Pentland. And he finished his PhD from Sabancı Business School in collaboration of Sabancı Behavioral Analytics and Visualization Lab under supervision of Professor Burçin Bozkaya. Professor Bozkaya is also together with us today, and it's a great pleasure and honor and to have Mohsen, and the scene is yours, Mohsen.
Thank you so much, Hocam. Thank you for having me and giving me this opportunity. So I would be more happy if I could be there physically, but I miss those like PhD years at Sabancı. So very good years. We started collaboration with Burçin Hoca, Professor Bozkaya, and then I joined like BAV, Behavioral Analytics and Visualization Lab, and started working with Selim Hoca. And after I finished, I started my postdoc at MIT. So first, I want to give some information about what I do. So what I do is actually called computational social science. So the history of computational social sciences starts with social physics. So by the rise of alchemy and physics, in that times, like centuries ago, people were thinking about like using numbers to understand human behavior and human nature. So they started collecting information or let's say data from the people. So that ended up in what today we call it census. But census data is very expensive to collect, and like for many countries it is like 10 years. Each 10 years they collect one's census data. So by the availability of computational techniques and also a lot of like now data sets, large data sets from banks, from telcos, transportation, and all other kinds of industries. So people could do like the data science and data-driven analytics. So what we do is previously it was called data-driven social analytics. It means like using data to understand human behavior in society. But then about 10 years ago, a new term or a new name was introduced for this science called computational social science. It is a mix of computational techniques and also social science to understand how human behavior is and what influences human behavior. So these kind of studies are interdisciplinary studies. Interdisciplinary studies are a bit are not actually that straightforward. It is like puzzles. Doing interdisciplinary studies, you have to like bring each part of a puzzle from different sciences and put together to have a clear picture. So let me pass. So first I want to talk about this Science Never Stops. So Science Never Stops was a good name. So I would like to take this opportunity to give a special thanks for like frontliner workers in the like COVID crisis and our institutions like who gave us this opportunity to stay at home and work on the science. So a special thanks to medical teams and also our institutions. I was telling that in MIT, provost and his advisory board decided to reduce their salary to help, let's say, spend the extra money on the research to help to help solve COVID crisis. So we are also doing our job in helping to solve these problems. We are doing different studies. So I joined UNICEF and UN Global Pulse as volunteer to study the effects of social distancing measures. So everything is available in the link there. So you can click on the link, and it is called Magic Box by UNICEF, and you can see what kind of studies we are doing there. It is fully volunteered research, and our institutions or us, we don't get any like credits of that. So the second study we are doing in collaboration with Saban GBA, VLab, and Boston University is understanding effect of social norms in respond of people to regulation regarding COVID-19 pandemic. So the idea is, for example, people who are living in a border of two states, and one state decided to order lockdown. If these people in the order are in contact with the other with the people in the other side of the border, and the other state hasn't given lockdown order, how do they behave? So this is one behavioral study we are doing. Also, we are trying to, together with MasterCard, we are trying to understand customer purchase behavior before, during, and after COVID-19 and lockdowns. And also, I'm helping MIT Big Data Living Lab in South Australia to help rebooting economy by something called, we invented this term. It's like called body neighborhoods. So after the presentation is over, we can, if anyone is interested and have questions, we can talk more about this project. So yeah, let's go to the project, to the main presentation. So it is called Merchant Life in the Network, Predicting Financial Well-Being Using Network Features. So the audience of this this presentation are like general academic positions, but I try to make it somehow more, more suitable for the PhD students or those students who are like early researchers, because this is very important to understand the ideas, and the ideas of research, they don't pop up in our mind most of the time. So we have to like iterate between the literature and brainstorm, and again iterate over the literature to come up with new ideas. And because this study is not finished, any kind of like feedback is highly appreciated. So this study started first with the news, with a piece of news on MIT Daily News, and it was a piece of news about papers which were trying to predict a new product's success or failure based on the customers who purchased that product. So they could show that there are like certain zip codes that if they buy those products, then those products will fail. So they call these people harbingers of failure. And then they started doing more data mining and more, let's say, understanding of demographic features of people and their behavior. So they showed that certain demographics and certain geographic areas, people who live there, they start buying the products which will fail, or they vote for they mostly vote for the candidates which will lose the campaign. So when we started reading this papers, we came up with this idea, okay, these people are trying to predict the fail or success of a product, but what about like stores itself? If we can predict a store success or fail, that would be even more impactful than a product. So we decided to say, okay, we can predict SME or small and medium-sized or retail stores success based on the demographic features of their customers. So why we decided on SMEs? Because SMEs, small and medium-sized enterprises, they are, they account for a large proportion of economic activity in many countries, and they are directly associated or related with employment and unemployment rates. So, for example, I have here the example of European Union, when as of 2019, we have 25 million SMEs, and these 25 million are 99.8% of all enterprises, like non-financial business sector. And they're responsible for about like 67% of jobs. So you can imagine if they can work very well, or if they fail, what would happen to this job or jobs or economy. So who benefits from predicting this, let's say, SME well-being prediction? So those benefit are mostly financial institutes or banks, because SMEs heavily rely on external funds. They mostly ask from banks for loans, and lenders ask for loans. So it is very important for banks and financial institute to predict if this SME will be a successful one or will be well performing in the future or not. Then they can, with this kind of prediction model, if they can accurately predict the SME performance in future, they can accurately, let's say, allocate their capital and also avoid the losses. So till here, we know that there is a study that uses customer demographics to predict product fail or success. Then we decided to do this for SMEs. Now we come and we go to the SME well-being prediction literature to see have they done such things or not. So back to the literature, we see this kind of prediction models are mostly defined as likelihood of defaulting or on a loan or bankruptcy. So most of these studies use machine learning techniques, and their input features are mostly private data from the companies, like earnings per asset, equity per asset, liquidity amount, those kind of which are highly private, and it is not available in small and medium-sized enterprises. It is mostly available in large organizations. So these kind of information are difficult to obtain, but we also find a paper which they do research with replacing this information with credit card data, and they say we can use credit card data to replace this revenue features. So now we see that we can use credit card data without knowing any internal information from the company to predict its future. Another group of the papers in the literature or research, they show that the area attractiveness is very important on merchant revenue. They show that, for example, people try to, instead of like going 3 trips for 3 different aims, they just try to combine those and just go 1 trip for 3 shopping aims. For example, they go for, let's say, in a place with 1 trip to buy their groceries, and also take get money from ATM and do for example, car wash. So they don't do like 3 different trips for this. In majority of times, they try to like combine these together. Also, they showed that proximity to other types of merchants and like points of interest have positive effect on merchants' revenue. For example, they showed that closeness of a merchant, like a supermarket, with a liquor store had a significant impact on the supermarket's revenue. Also, for example, when a supermarket is close to a historical place, it is the same. It has the same, let's say, effect. So we know that now these are the physical attributes that can have impact on the revenue. Now, after all these things in the literature which are related to let's say prediction and also performance of the prediction of performance of merchants, now we have a body of literature which is not related to merchants, but it is like it is mostly related to individuals. So that is networks. So we know that this kind of study is done a lot in our group. So we were thinking of that because networks are considered as backbone of the social and economic life, and networks can give us like very valuable information about the economic and also the performance of the individuals and also community. Can we use this kind of like networks for the merchants as well? Because most of the times these networks are only about individuals and communities. So we were thinking of, okay, we have like different previous studies, they use different features. Now networks are very informative. Can we create a network of merchant that is similar to social network, and it is able to give us very important information about merchants. So I will answer this question later. So what data we used here, we took data credit card transactions from 2 leading Turkish banks. So we have like customer information including hashed customer ID, customer age, gender, marital status, job type, home location, education level, and income. And we have transaction table, which is transaction details, which is hashed customer ID, spending amount in each transactions, merchant ID, and also MCC, which is merchant category code, like if it is like grocery, if it is like dentist, lawyer, hospital, and also its location. And also finally, time date of transactions. We have 2 banks. So bank 1 has like 3 months of transaction records, and bank 2 has 1 year of transaction records. So in the experimental setting, first we have like filtering rules. So for both of the cases, we take Istanbul as the location of a study, and we filter out non-discretionary and also non-SMEs. So for example, government agents and factories. These are things like we cannot decide by our will, or the factories are not SMEs. So we remove this kind of merchants from the old merchant list. And also we consider for the bank 1, 25 transactions per 3 months, and for the bank 2, 100 transactions per 1 year as a threshold. And if a merchant has less than those thresholds, then we remove those merchants. After filtering out, we have 1,200 merchants in dataset of bank 1 and 4,300 merchants in dataset of bank 2. So how do we define our labels? So what we want to understand is we want to predict the future performance of the merchant, and we interpret that with revenue improvement rate. So what we do, we divide the whole period of data into 2. For the first bank, we use from the 3 months, we use first section of 2 months and the second as the last 1 month. And for the bank 2, we used 6 months and 6 months as first and second half. So we want to understand what goes on in first half and then predict what goes on in the second half. So what we use, the measure is average monthly revenue in the first half and then in the second half. And then we want to see what is the improvement rate between those 2. So it is not only about like positiveness or negativity of this improvement rate, but it is evaluated based on the median value of the merchant performance. So for example, maybe in a bad economic situation, all merchants have like negative improvement rate. So we evaluate that based on the median level of improvement. So the merchants which are like better than median, so we turn them into 1, or like successful merchants, improving merchants, and then below median, we say like bad performing merchants. So we have a binary label here. And now we go back to our literature review and start extracting features. So first is like customer features, which learned from the harbingers of failure study. So we have gender diversity, education, marital status, employment, home and work district of the customers, home district ID, and also age and income statistics. So that is to understand how we can use those kind of features to predict merchant future performance. Second one is revenue features, which we had like two groups. First was using credit card transactions and transaction based, which is like monthly revenue. It is total amount of transactions for in that merchant, number of transactions, number of unique customers, and mean and the standard deviation of monthly revenues. And also we have MCC codes. So we can separate by the industry or category of the merchants. And we also add area attractiveness. So we draw a buffer of 200 meters around a merchant and then count the POIs inside that area. So what are the features gotten from that buffer? Those are total POI count inside that buffer, number of each POI type, and POI diversity, and also we have finally merchant district ID, because we want to be able to distinguish if between those districts which performing well and districts which are not performing well. And here comes our contribution. So our main contribution is this network, a network of merchants. So how do we create that? We actually take the intersection of customers between the merchants. So if there is a customer that has credit card transactions or purchases in two merchants, that customer connects those two merchants, and it is a weighted network. So the number of the intersected customers is actually the weight of the edge. So creating this network, we go and take this network features, which are, so you can see in the right, you can see an example of how our network looks like. So it is a part of the network of merchants. And also we have like MCC description on the left. So features are degree, eigenvector centrality, closeness centrality, betweenness centrality, ego network, category diversity, and geographic diversity. Category diversity means to how diverse is the category of the directly connected merchant to that merchant, and also how geographically they are dispersed over the map. So we have now three sets of features. We put those in machine learning methods, and we use the best performing one is gradient boosted trees, GBT. So we report the results for those. So for the bank one in the left, we can see that revenue features area, we report for both of the cases area under our C curve. So for the bank one, again, we have revenue features working better than customer features. Customer features are a bit better than throwing a coin. So we don't have harbingers of failure and success in Istanbul. And network features perform better than those two. And also we have combined, which combination of those three can improve, can like have a very slight improvement on the network features. For the second bank, we also have the similar trend, while the difference between network features and combined features area under curve is 0.006, which is very low, and it shows that the network features are performing very well, better than the other feature sets. So as a discussion, so we showed that the network features are able to capture financial well-being of merchants better than the other feature sets, which were previously used for predicting merchant and product success. So what we think, we have this kind of explanation why network features are able to capture. So what we explain or we discuss in this area is ego network measures, for example, the degree of a merchant is a proxy of revenue of the merchant. And also the attractiveness of merchant is captured by the diversity of its connections. So as much as a merchant is attractive, then it can attract like more and more diverse customers to itself. For example, about eigenvector centrality, we say eigenvector centrality is let's say roughly encodes the probability that a random customer will visit that merchant when comparing to other merchants in the similar merchants in the network. Betweenness might capture the information exchange between customers and merchants. For example, like why this is important. For example, there are gym and there's a gym and we have a supermarket and we have another type of gym in the other part. It is like considered like different parts of networks connected by one merchant, and this can bring information to the merchant, to the supermarket, that can provide let's say gym supplements, food supplements like protein bars to attract more customers. Also, the closeness centrality, it may capture how far a merchant is on average from the other merchants in the network. So these are our understanding from the networks and how it works better than other feature sets in predicting the SME financial well-being. So we didn't stop here. We started doing a building a visualization tool. Now we have a visualization tool that we can use it to understand how merchants behave and how their networks look like. So let me show you. So if you see in the left, we have in the left up we have A, the panel A. It is for showing the merchants on the map and their network on the map. Panel B, in the middle, we have the network. So for example, this one is July network of the merchants. Panel C shows the distribution of centrality measures and also transaction measures. Panel D can shows the pixel for it starts from first month and to the 12 months. It shows the increase and decrease in, for example, revenue, average payments, number of customers, centrality measures for each merchant. We have panel E, which we can see monthly shape of the network of merchants, and also in the panel F, we can filter out and we can choose by let's say month, MCC type, and also we can change the shape of those nodes by the label, which is success or fail. So I can so let me just show a short video of this tool. So here you see we can choose by the centrality measures, and they are shown on the network, and also they are shown at the same time on the map. And also we can choose the merchants by clicking on them and choosing them on the network panel and see them on the map and their performance and also their monthly network shape. So all this together, if you have any questions, any feedback, this is it. So yes, waiting for feedbacks and questions.
Thank you very much, Mohsen. There is one question from the audience. How did you decide on the time frame of periods? Could you explain more about cross-validation of the model?
Okay, so if we want to talk about cross validation and the gradient boosting trees, we use like tenfold cross validation for this. And for the time frame, we decided to do it like equally similar to be fair about this. But for the bank one, if we wanted to put it like 1.5 months and 1.5 months, so we were losing a lot of merchants. So we decided to do it like 2 months to first have good understanding of the merchants, uh, let's say better understanding of the merchant's performance, and also keep the enough number of merchants in the data set. Otherwise we will lose a lot of that with filtering.
Okay, and there is another question. Can we reach the visualization tool? Is it online?
So the visualization tool will be presented in EuroVA, which is a visualization conference as workshop in 26th May, I think. And then after that, we will try to, so the first aim is to make it online and available for everyone, but it will, it will know afterwards how long would it take to put it online and available for everyone.
Yes, maybe with some synthetic data we can put it online. I don't think we can put it with the bank's data. There is a question. I was wondering, have you considered using graph embeddings into vectors as features in your machine learning model?
No, we didn't. So we just use this network features, as I told, so we didn't do that.
It's a good question.
Yes, it's a good question. Great question.
Yeah, thank you.
We can consider that.
Yeah, let's take a note on that.
Yes.
Okay. And maybe you would like to talk a little bit on, you mentioned in the beginning of your talk about SME's role in the economy. And maybe in this, if we can connect it back to the COVID crisis, and how do you see SMEs in the reopening of the economy? Because now you are very much into this data, what is your insight?
So, it is really difficult to say because people's behavior would change, and it is different from place to place. So, for example, I'm working closely with government of South Australia. So they are losing a lot of jobs because the tourism industry has a majority of their economy. So and the tourism industry is not that would open very fast. They have had 14 days of zero new cases, so they started reopening. But the question is how we can address the unemployment on the SMEs which are related for tourism industry. So what we are doing is we are assessing the skills of those people who were working in the tourism industry to somehow, have them join other industries which matches their skill set, for at least temporarily until we have the tourism back. So we also try to do this with some term we called it body neighborhoods. So which body neighborhoods which have, so consider different neighborhoods. One neighborhood is like financial, and they have like a lot of like let's say financial sources. The other neighborhood has like universities and a lot of university educated people. So we try to connect these neighborhoods to each other, which have like complementary resources to help the economic reboot. So this is what currently we are doing. The problem is it is really unpredictable. So we don't know what really, so human behavior is changing. What would be social norms and what would be new norms after pandemic, and even like how long would it take? So for example, in the first here, I talked about this one, the research I'm doing with UNICEF. What I'm doing, I am trying to work on Twitter data to analyze how people's feelings are changing over time, because we have studies that show if this isolation of this quarantine, like it lasts more than 3 months, other than unemployment, it will it will have several and also serious um, problems, will cause serious problems for our health, our mental and physical health. And other than that, so that there was a study that's showing that as the unemployment rate increases, it directly increases the number of suicides. And and each person commits suicide, there are like number of people think about suicide. So it is really unpredictable, but hoping to, help world to pass this problem with the studies we do, and hopefully we will have this, vaccine soon. But really, it is unpredictable. So this we with the Mastercard data, we cannot use the previous behavior of customers to predict their behavior during and after lockdowns, and we have seen that. So the behavior will change, and we really don't know what would happen. So, for example, one of the things is people now, most of the people are doing cooking at home. So how do we know that after the pandemic, all those people who were eating out, now they will go back to the restaurants? It is unknown, because now they know they can cook. This is very unpredictable.
We live in unpredictable times.
Yes, of course.
I know I will go back to the restaurants. I'm tired of cooking at home.
Yes. Okay.
Mohsen, I have a related question to this unemployment business. I mean, it's very important for SMEs, right?
Yes.
Do you think one can set up a tool that would easily allow SMEs to assess their situation currently, let's say in the marketplace, how likely they're going to be able to recover, given some of the indicators that you mentioned, like their position in the network, the point of interest around them? I don't know, maybe some kind of external data sets like mobility data sets that are available. Obviously, it wouldn't be a free tool. Maybe this will have to be turned into some kind of a product. But do you see any potential in this?
Of course, that is very good, suggestion. But for now, during the lockdown, it seems impossible because they don't work. They are closed, so they don't have any like network shapes. But maybe with signs after, with first signals after like opening, we can do such a study and use those signals to predict SME's future well-being, maybe. Yeah, but it was a really good study. I think, that kind of like decision support system, or let's say prediction system, it would be very good.
Because I mean, like we discussed and you mentioned before, the new normal is different, right?
Yes.
So it's like people will not be going to small mom and pop shops, restaurants, because they're now used to cooking at home, and similar things. Even cutting your hair, right? You don't even have to go to barber as frequently. So I mean, given this new normal, I guess it would be hard to verify or validate these models, that tell something about the future of an SME. I'm just curious, what is the potential here to make some adjustments, with these new data sets that are out there now, that to help out SMEs in that regard?
Of course, I think that the Mastercard study would be of help definitely for this kind of situations.
Sure.
Yeah. So because that is fresh data, these old like 2013, 14, 15 data, we don't even know like after, as I like suggested, one kind of these studies is to replicate our previous studies with the new data sets and see really. So for example, if we have like 2014, 15 data for bank, and we see some kind of like behavior from customers, would we see this similar behavior like after 1 year or after 2 years after pandemic? So probably not. So probably many types of normal behavior in the society will change.
Yep.
Okay. Thank you very much, Mohsen. And thank you, Burçin Hoca, for joining from Florida.
And my pleasure.
And Mohsen from Boston. And it was a nice presentation. And we will have another session on Science Never Stops in 2 weeks, June 1st, from Ogün Hoca, Ogün Adabalin, and he will talk about the COVID virus and his research on the COVID virus spreads and mutations, I would assume. I don't want to say anything wrong, but it will be, again, a motivating talk on science. And thank you for participating. Thank you for everybody, and have a good night. Goodbye.
Thanks.
Thank you for having me.
Thank you.
Thanks, Mohsen.
Thank you.
Thanks, Mohsen.
Bye-bye.